Today I'm going actually to give a presentation about zero trust security, and I'm going actually to highlight two of the use cases that we use the zero trust model for. The first use case is for the open 5G architecture, and the second use case is for the drone-driven 5G network. So, can you just open the presentation? Yeah. So in this talk, actually, I'm going to introduce the zero trust concepts, the security elements included in the zero trust model, the difference between the zero trust model and the conventional or traditional security models. I'm going also to highlight the description or the definition of the 5G from the Department of Defense perspective, and also will introduce the zero trust model from National Institute of Standards and Technology perspective. So just for the sake of the time, the zero trust challenges will be also discussed, and some real-time use cases will be also discussed. So the outline of this presentation actually includes the definition, use cases, NIST perspective for zero trust, the comparison between zero trust and the conventional security, use case 1, use case 2, and the element of the continuous authentication for the drone-driven 5G network. And there is a practical demo. If time allows, I'm going to share this demo with you. This demo was part of hackathons that was actually running on France. We ended in the first position with our State University of New York students, and I will be happy to share this demo with you. In this demo, we actually compromised the 5G component on the fly based on the containerized software systems, and they actually detect these attacks. So it is like a kind of red and blue team experiments, like offensive and defensive experiment. So the first use case here actually is applied to the open 5G architecture. And the open 5G architecture, it's a new concept actually introduced by Department of Defense. So we recently received actually $1.1 million as a single investigator from the Air Force Research Lab in order to develop the security part of this open 5G architecture. So there are other collaborators here in this project, Virginia Tech University and University of Arizona. So the idea of the open 5G architecture means that you want different 5G network to work together. Like think on a scenario, something like Orange and Vodafone as an example, they want to work together. Like Orange want to use the access point or the antenna of Verizon, or Verizon may use actually some other resources from Orange. What if you are in a certain area where there is no coverage for the network, okay? Like rural area as an example, and you just have like some antennas from Verizon and you are an Orange user. So in this way, all these components can work together, can be integrated to introduce the best service, the best 5G service to the 5G users. Another scenario, which is actually the use case here that we are focusing on from the Department of Defense perspective. So the US Department of Defense, they are working on a model which actually allows them to work with their alliances in the NATO and also other alliances like in Philippines, in Taiwan. So they want to share their resources with these countries, but at the same time, they want to make sure that the confidentiality, integrity, and availability of their data are intact. So the zero trust model is the next generation cybersecurity techniques that the Department of Defense actually defined in order to provide such kind of security functionalities. So the open 5G architecture that they are currently developing in order to allow them to work with some other commercial companies like Verizon, AT&T, and to share the resources of these companies, and at the same time also to make sure that their resources are intact. So using this open 5G architecture, they can actually orchestrate the network slices from the Department of Defense with the other commercial companies. So what are the main challenges that they have? So the main challenges here include the security. So as you can see here, the security or zero trust, the trust issues in the 5G vendor. I don't know why this one does not. Yeah, so the first element here is the security and the trust. And the second element here is the service federation and orchestration of this 5G, of this open 5G architecture. So for the first element here, we address this using the zero trust security framework. And this is one of our tasks at SUNY. And the second task here is to develop like an end-to-end federated network slice orchestrator, which allow actually the Department of Defense to orchestrate these services with different commercial companies. The second two challenges are related to the handover and the mobility scenarios, and this is handled by Virginia Tech University. And the third element here is related to the scalability and the ability of the network to handle actually huge number of user equipments. And this is actually handled by University of Arizona. So this is the first case. The second case here is for the drone-driven 5G network. So for the drone-driven 5G network here, the drone actually is equipped with a 5G base station in order to provide 5G coverage for some areas where there is no like internet connection or there is no internet coverage on this area. So the drone actually carries this flying base station to cover this specific area. So we apply the zero trust concept here also to this drone-driven 5G network. And this actually is part of a very large project that we are currently also working on with Purdue University, Augusta University, University of Arizona, and National Institute of Standards and Technology, NIST. So we received actually $2.7 million for this project. And currently we integrate this work with METRI. So METRI recently received $70 million from New York State. And the goal actually for this project here is to develop a very large corridor between Rome City in New York and Syracuse. So it is like 50 miles between these two cities, and this actually distance is covered by the drones. So they develop like a corridor for the drones to be used for mobility, to be used for internet or 5G coverage, and also to make sure that these corridors are collision-free. So we integrate our work actually with METRI. METRI is actually a company which works with the Department of Defense for military applications. So the zero trust model is also applied to this second use case. So now I'm going actually to introduce the zero trust concepts based on National Institute of Standards and Technology. And the reason why I'm specifying this for NIST, because the definition of zero trust, actually, there are different definitions of zero trust from different perspectives. Like if you look at Cloudflare as an example, they give a different definition for zero trust. If you look at the Department of Defense, they have another definition for the zero trust model. So just to follow the standards, so the definition here is given according to National Institute of Standards and Technology. So according to National Institute of Standards and Technology, zero trust means to always verify and never trust. What does it mean? It means that you should not allow any of the network entity or any of the computer system entities in general to access to the network without applying a continuous verification of their authentication and their authorized roles in the network, okay? And zero trust, according to NIST, they have already actually introduced two main components here. So the first component here is the BDB. I don't know what, yeah, it's the BDB and BEB. So BDB is a policy decision point, and the BEB means policy enforcement point. So the BEP policy enforcement point it is a component which makes sure that all access requests are handled and verified by the BDB component or the policy decision point. So whenever you have an access from one component to another component in the network, so the BDB will decide whether this access request actually align with the policy of this organization or not. Okay? So any access from the local area network or from any subject, users, applications must be verified using this BEB and BDB components. What are the zero trust principles? So the zero trust principles here actually include the least privilege, integrity check, risk assessment, trust evaluation, and dynamic policy. And each of these components actually has a certain concepts related to the zero trust. So for least privileges, as an example, this means that you should not allow any entity in the system to have a full access of any components. You just allow the least privileges for this entity to use to access to a certain part of this network or a certain part of your database. Integrity check means that you have to check the integrity of this data to make sure that this data has not been altered or modified during the transmission. And risk assessment means to evaluate the risk in a quantitative way, not a qualitative way. Because the traditional system actually evaluates the risk assessment and the trust as well based on qualitative way. Means it actually shows like the level of the trust or the level of the risk as like low, medium, and high. Okay? But for the zero trust model, it will quantify this with a numeric value, very accurate numeric value, like 53.3 trust risk value or trust level value. So there is a numeric value actually that actually can be used later on to decide the trust level of a certain organization. And then the dynamic policy. The dynamic policy here means that the policy must be updated, okay, as you go. And the role-based access control components here must be integrated and work in a continuous flow based on the zero trust model. So if you look at the history of the zero trust model, so starting by Jericho in 2004, so this model has been actually improved. So they introduced the concept of de-perimeterization, okay, which means that they remove the implicit trust of the entities in the network, and we should not rely on a single security component, like an authentication only, authorization, access control. You have to actually integrate all these components to work together. And then this concept has been actually improved by Forrester in 2009, and then by Google, where Google actually introduced some best practices to implement the zero trust model. And after that, by NIST in 2020, where they introduced the BDE and BEE components that I was just discussing before, and they actually put some standards for the zero trust model. And then by Department of Defense in 2022, where they actually summarize the overall architecture based on 5 security components or 5 security controls, which is based on the identity of the system, the protection, detection, also the evaluation of the OR system, and then the countermeasure detection or the mitigation of these attacks in an autonomous way. So if you look at the size of the market of the zero trust model, so the size of the market is actually increasing. So starting from 2022, it was $25.12 billion. And in 2032, they are expecting that this will actually increase to $118.5 billion. So the size of the market is actually increasing. And the architecture itself is actually used in different models, in different applications. Okay? So nowadays, you can see the zero trust model is applied everywhere. Like as an example, the mutual authentication approaches that you use when you access to any system before it was just asking you like to provide the username and password, right? But later on you have to verify this access by sending you like a certain verification code to the email, or giving you a call to make sure, or to send you the verification code to your phone. So there is like a mutual authentication approach. This is part of the zero trust actually model, okay? So what is the difference between zero trust and conventional cybersecurity? So if you look here at the conventional security controls, for the users actually who are actually within a certain borders here, they use the concept of castle and moat. So the concept of castle and moat here means what? Means that the system here, or the users here, castle and moat, castle here represents the system itself, like the network, okay? And the moat here is the perimeters, the security perimeters that are used in order to protect this network, like the intrusion detection system, intrusion prevention, firewalls. So according to the conventional security system, as long as we are inside the system, inside this trusted system, you can access whatever components that you want, okay? But when the zero trust concept comes here, they actually remove this implicit trust. Why? Because if the attacker was able actually to bypass this moat or this perimeter security by bypassing the firewall or the intrusion detection or prevention system, so the attacker can use this trusted permissions to access from one element to another element, right? But what happened here actually is that the zero trust model does not allow this trusted component or these trusted entities to access to the other entity, and it always verify the authorization and authentication of this component. So this is one of the first differences here, is that the implicit trust here is removed in the zero trust model. The second scenario here is the lateral movement. So in the conventional cybersecurity systems, if you access to a certain component here, so as an example, if you access from one entity to another entity here, and this entity actually is already trusted within the trusted network, so this entity can access to the other component, right? So if the attacker actually compromises one of these components, so he can access to the rest of the component, right? But with the zero trust, because you are always verifying this access permission and access request, so it will actually, sorry. So it will actually deny this access. Don't know what is this one. Okay. 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 So this will be actually denied if you try to access from one entity to another entity, because the zero trust principle here is applied, so these entities will not be able to access to this component. Okay? So the lateral movement of this attack will be actually will not be implemented with the zero trust model. Okay? So the third scenario here is when you use actually the virtual private network here. So with the virtual private network here, you know, you can use the virtual private network to bypass the firewall, right? If you are accessing from any point in the world, so you can use a virtual private network to bypass the firewall, and you can access to the network, right? So with the zero trust model here, this implicit trust is actually removed because it uses the policy enforcement point here. The policy enforcement point here is not based on the location of the user. So it will always verify the user, the accessibility of the user at every single point to make sure that the user is allowed to access to this component. So regardless of having a virtual private network or not, so the zero trust model will not allow you to bypass the firewall permissions and the policies of the system. If you look at also a third scenario here, where you have the security component are actually totally distributed. So these are like network-centric and isolated policies. So these components actually are not integrated to each other. So with the zero trust model here, these components actually work according to a certain scenario. So in the first scenario here, so data here, in the first scenario, data is actually vulnerable to some attacks because the standard role-based systems here is not updated as you go, okay? But with the zero trust model here, you have like a continuous assessment approach, so the role access-based and policies are updated as you go. And also here, if you look at the trust quantification approach, which is used in the traditional models here, so these are quantitative, as I mentioned before, so you have like the trust and the risk in terms of like low, medium, and high evaluation, just. But here, you have a quantitative evaluation of this trust model. Well, so also, if you compare the traditional system here, the decentralized and siloed applications in the conventional security models here, these components are isolated. But here, when you look at the zero trust model as the other side, so there is like a dynamic feedback loop that actually connect all these components together. So there is like authentication, authorization, access control, policy enforcement. So all these components actually are integrated and updated and working together instead of this isolated component. In the conventional model. Well, so let's see how the zero trust model is used for the first scenario. So for the first scenario here, I will focus on the trust quantification approach. Because if you remember, the trust elements include the identity check, continuous authentication, quantification of the trust. So here I'm actually introducing a model which evaluates the trust, which quantifies the trust values. So in order to do this, we use actually our ECRL testbed, and we actually developed a virtual network. And this virtual network actually uses some open source system for the 5G network. Some of these components are actually based on systems like open source Mano, OpenStack Cloud here, and FlexRAN. So the open source Mano is used for the network slice virtualization and orchestration. And then OpenStack is used to manage and control the virtual machines because it's a cloud, a private cloud infrastructure. And also here we have the federated model. So the federated model here actually consists of some global models and some local models. So the training model is actually updated and trained at each technological domain of the 5G network. So we have here like different technological domains. So each of this technological domain is equipped with some specific component. Why? Because we want to actually evaluate the scenario where you have like different type of 5G network connected to each other. So some of these technological domains are based on the IoT component, some others are based on the drones, and a third example here for like medical use and for to connect the hospitals together. So different scenarios actually for the 5G network. And then we have this hardware testbed, which belongs to the Air Force Research Lab. And for us, in order to implement the open 5G architecture, you should have like two different 5G networks, and you need to connect this network together to implement the concept of the open 5G architecture. So we use the virtualized 5G testbed, which I described in the previous slides, and this one is a hardware-based testbed. So the cost of this testbed is $570,000, and it's a very unique testbed. And we use it actually in order to test and evaluate the deployment model and the zero trust model that we implemented using the virtual network. So in order to connect this network together to simulate the open 5G architecture scenario, so we actually use this hardware testbed, and we can connect the hardware testbed here, the left hand side. This is the hardware testbed, which belongs to the Air Force Research Lab, with the software-based one. So in order to do this, we developed like an intermediate layer which connect each component from the software-based 5G testbed to the hardware testbed. So the radio access network component, the cloud infrastructure, the software-defined network, the virtual network functions, all these components are connected to each other using this middleware layer, which actually try to convert from one language to another language. I mean, to just use one or the same language that these two components can actually talk or can work together. So we developed this model in order to build the open 5G architecture, and after that we started to develop the zero trust architecture. So the zero trust architecture, as you can see, there are a lot of components which are related to the monitoring process, identity check, detection, classification, autonomous mitigation, and policy enforcement, okay? And it is based on the concept defined by NIST, actually. So we started to develop this model actually in 2020, and we are almost done actually with this zero trust model. And it's part actually of the Department of Defense project. And we actually here, as you can see, there are different domains. So there are different technological domains here, right? Each of this technological domain actually implements some 5G components, and we try to actually integrate this heterogeneous infrastructure, like heterogeneous operating system, heterogeneous software, heterogeneous hardware, and we try to integrate all of them together using this zero trust model. So for the sake of time, I will actually quickly bypass this one, but I will just focus on the evaluation of the trust. How can we quantify this trust? Okay. So in order to quantify this trust, we follow the NIST definition of trust quantification. So according to NIST, there are two main elements that you have to consider when you evaluate the trust. The first element is the direct element, which it means directly related to cybersecurity domain, which also means that you have to evaluate the vulnerability, exploitability, and attackability ratio in your network, so that you can end with a trust value which refer to the quantification or the security quantification of this 5G domain, okay? And why we need to evaluate the trust here? Because we want to end with like a provisioning framework which can help the Department of Defense to choose the best service provider which can provide the cloud, the radio access network resources, the software-defined network. So you need to quantify the trust value or the trust level of each of these vendors so that you can end with a decision which ones that you can choose, right? So the zero trust here is actually, or the quantification of the trust is used in order to define or to choose the best vendor, okay? There are some other elements, of course, that are considered besides the security trust, like the cost and performance as well, okay? So here for the security, there are direct elements which is related to vulnerability, attackability, and exploitability, which is the SRV here, which refer to the network slice real-time viability metrics, okay? And the other two parameters are indirect parameters. What does it mean indirect? It means that they are not directly related to cybersecurity. Like what? Like the service level agreement violation as an example. How many times this vendor has a service level agreement violation, which will impact the trust level of this vendor, right? And also the user experience, which is the third parameter, AXP. So the user experience about these network slices. How many times these network slices have been dropped? And how many times the user accessed or requested a certain resource and he was not actually granted access to these resources. So this is the user experience. So we consider this direct parameter, which is directly related to cybersecurity, and two indirect parameters, which are related to the service level agreement violation and user experience. And then we end with a summation equation based on NIST, because in NIST equations, they sum all these direct and indirect parameters to end with a trust value, which is T here. And this trust value will define exactly the trust level of this vendor, okay? So how can we quantify these three parameters? So for the first parameter here, which is the SRV, we use our intelligent vulnerability assessment approach, which actually we developed as part of this project as well. So, and according to this approach, we evaluate the trust based on the accessibility of the attacker to a certain component in the network. So if you look at the attack tree here in the level, so the attack tree here refers to some component where the attacker can start the compromisation from a certain point until he reach out to a certain point. Like he can start from the workstation within the 5G network until he shut off the antenna, the 5G antenna. Okay? So now we want to compute the shortest path for the attacker, the shortest path that the attacker can consider in order to shut off this antenna. And shortest path here, it does not mean the distance. It means the cost that the attacker actually will pay in order to shut off this antenna, like the computational power that he needs, the time that he needs. Okay, so by considering all these parameters, so it is like a multi-objective criteria problem. So the attacker will end with a decision, okay, to compromise the network, and based on this decision, we compute a value which is called the compromisation probability. And the compromisation probability is actually the value of SRV here. Okay, because the compromisation probability here means the attackability ratio, the exploitability ratio, okay, and the vulnerability ratio. So it is like an equation. I don't want to go through the mathematical sophisticated details, but this ratio actually explains exactly the SRV factor, the security factor. Okay? And then for the other two factors, which is the service level agreement violation and the user experience, we compute the service level agreement violation here based on what? Based on like a certain reward or a certain penalty. So for the vendor, whenever you respect the service level agreement, there is a reward added to the trust factor. And if the service level agreement is violated, so there is like a penalty added to the trust value. So you end with the SLAT, which is the service level agreement violation factor. And then for the user experience here. So the user experience here represents the experience of the users with the network slices. So some users may give actually like very high like evaluation for the vendors or very low evaluation. So you need to like to normalize these values. Okay. So to actually to match the overall feedback of the user to make an accurate trust level. So we use this artificial intelligence model here in order to normalize this feedback from the users. So if you look at the output of this actually model, so on the left-hand side here, the service level agreement violation. So this one here, service level agreement violation. So the orange line here represent what? The orange line represent here actually the level of the service level agreement violation. So when there is a violation in the service level agreement, the gray line here represents the trust. So the trust will be dropped. And when the service level agreement was respected here, for the orange line here, so the trust was increasing. So this actually shows the service level agreement violation factor, the impact of this factor on the overall trust evaluation. And in the right side, this is the user feedback. So the orange line here represents the random feedback received from the users. Okay? And the blue line represents the normalization of this feedback. Okay? And then in the third component here, which is actually used to evaluate the security, vulnerability, exploitability, and attackability. And by combining these three parameters, we end with this evaluation. And this is exactly the trust level of each 5G vendor. So we combine all of them. But why we use weights here? So why we use these three weights actually in order to evaluate each of these parameters? The reason for using weights for each of these parameters is because you are applying this to different use cases. So let's see if you are applying a use case to like a bank system, as an example, who is going to use a 5G network. So security for the bank system will be more important than user experience, right? But what if you are applying this to like a video website or a video showing or video or moving kind of like a theater or a film showing website or something like this. So the security may not be important comparing to the user experience. So I mean, according to the use case. So the weights here are defined according to the use case that you are applying the trust quantification to. So the weights here can increase or decrease based on that. So now you end with a quantified value for this trust model. So let's see how can we use this zero trust model concept for the second scenario, for the drone system. So So in the previous scenario, we just focused on just one element of the zero trust model, which is the trust quantification. In this model, we are actually highlighting the continuous authentication, like to make sure that everything was verified and continuously checked against the policies of the system. So in this continuous authentication model, the drone system, as you can see here, these drones actually are carrying 5G base stations, and they are covering a certain area, okay? And there are some attacks here that actually can compromise the network. So the attacker can actually compromise the cell phone, or the attacker can actually compromise the connection between the control system, the ground control system of the drone, and the radio frequency signal from this controller to the drone system, okay? Or the attacker can also compromise the 5G core network itself, right? Or can compromise the 5G base station. So this is the attack surface of this use case. So in this use case, you have different way for the attacker to compromise this network, okay? So let's see quickly how this system actually works. So here we use actually the blockchain model here, as you can see, in order to always verify the payload and to make sure that each component here in the system is verified, as authentication and authorization of each component is verified, and to make sure that there is no any illegal access from any drone or attacker drone system, because the attacker here can use even a drone in order to attack this radio frequency, right? So the blockchain model here is used to actually verify this payload, which is transmitted from the drone to the 5G base station, or from the controller to the 5G base station, or from the cell phone to the base station. So you have different scenarios here of the connection, right? So here we actually collect all this information, and we have like a UAV detection unit. And the UAV detection unit here is actually used in order to, for each UAV, there is a UAV detection unit to collect this payload and to apply the zero trust concept to always verify the connection of each of these elements to the drone network. And then we actually follow the 3GPP, definition of zero trust for the 5G network. So according to the 3GPP, there is an authentication model actually here, which is actually used in order to verify the authentication and authorization of each of these components. So we apply the authentication model here. I'm not going to go through the sophisticated details of this model, but as you can see, there are different entities here. User equipments, which means the cell phone or iPad or iPod system, any system that you use in order to access to the 5G network provided by the drone here. You have also a 5G base station, which is a terrestrial radio access network resources provided in the ground. And also you have the 5G core network, which actually collects all this information and provides the 5G features for the drone system, okay? And then here in this model, actually, this is the authentication scenario, okay, which uses the encryption scenario. So this information is encrypted, and there are some kind of exchanging of the encryption keys between all these entities to define whether this session is verified or not, to open a connection between the user equipment, cell phone, and the 5G core network. Well, these are the current ongoing research funds. I'm quickly just going to highlight these projects that we currently have for potential collaboration with you guys. So we have the first project here, actually by the Air Force Research Lab, which was funded by $1,073,000. And the second project actually is funded by New York State. It's a seed grant actually with $60K. And the third project here is actually for the 5G testbed provided by the Air Force Research Lab. The third one here, or the fourth one actually, is funded by National Institute of Standards and Technology through their iZone company. And the fifth one here for developing self-resilience framework, funded by the ONR Global, which is the Office of Naval Research Global. This office in London, actually. And we do this collaboration with the American University in Cairo. And the last one here, it's a fund with a total amount of $1.3 million from the New York Workforce Development Initiative. And we use this fund, actually, we used it to develop all these infrastructures. Prior, we have the Air Force Search Lab test bed. And these are the projects that have been already completed. Some of them are in the cyber physical domain, cloud computing domain, and 5G domains. So these are the funds and projects that are actually completed in our ECRL lab. These are the projects that are currently going in our research lab, the ECRL, Advanced Cybersecurity Research Lab. So the first one is related to the Open 5G architecture. Second one is related to the Zero Trust model. Third one for the UAV security. And fourth one related to the water test bed, SCADA system for water test bed. And third one for smart vehicle systems. And our main goal now is to connect all these components using the 5G, the hardware 5G network. So instead of using the wireless connection between this component, so we try to modify this control, and we are currently working with the 3GPP actually in order to build like a protocol which can allow you to connect all this heterogeneous system based on the radio frequencies, the 5G radio frequency. And yeah, so this is the drone system, and this is one of the opportunities actually that we may actually leverage. We can all work together through this call. So this call actually is a joint call between actually ready to do this collaboration through the NSF, and our research office can work actually on this if you guys are interested to do this kind of collaboration. And we have actually a lot of components that actually align with this goal. These are the potential funding agencies that also all of us can work together through. The Air Force Search Lab, Argonne National Laboratory, Office of Naval Research, NIST, some other core from NSF, like the SATC and NSF engine. These are the cores that align with what you are doing here in the current project. Also the BNL and Qatar National Research Fund. Thank you. And I appreciate the time that you have actually given for the presentation. So now it's time for questions. So please feel free to ask any question. Yes, go ahead.
So the floor is open for questions. The mic is coming right now. Sorry. You're welcome.
Yes, thank you.
It's working.
It's not. No, it's not.
1 second.
Well, maybe I just speak up.
Just wait for transmission.
Maybe you can use
The mute button is.
Yeah, so thanks very much for this very interesting talk. I was wondering, when you calculate these this trust number, basically, you need to have historical data. What do you do if you don't have that? If there's this basically favors known vendors.
Yeah. Thank you for this interesting question. So yes, so in the classification and the detection model here, there are two approaches, the supervised and unsupervised learning model. So the supervised learning model actually is based on this training data. That's true. But here we use also the unsupervised learning model. So we integrate the supervised and unsupervised in order to apply this kind of training if you don't have a data set for the training. Does this answer the question? Okay, so for supervised learning, you have to use a data set, right, for training, to train the model for the classification and detection, right? But for unsupervised, you don't need for a data set for the training. for the unsupervised one, you are actually building the model based on the overall behavior of the system as you go in the online system. Yes.
Yes, but my understanding was that with this trust number, maybe I misunderstood it completely. With this trust number, you basically make a decision what vendor you are selecting. And so if you have a new vendor, you cannot have numbers. You can also not really extrapolate from anything because there is no prior knowledge. So how do you do that then? Or does that mean you only can use vendors that you know and that have a track record of X years?
Thank you. So yeah, you are totally right. So we have the supervised learning model for some, like the user experience as an example. You must have a prior data in order to make a decision, right? For the service level agreement violation, you must have a data, right? So this is the supervised learning models. So you must have a data in order to train the model. But for the security, because you are running on the fly, right? You are actually detecting based on the signature-based detection or the knowledge-based detection. So once you have like a signature or you have some kind of data or some kinds that match with the signature, then you just fire the alerts and then you evaluate the severity of this alert. So this is for the unsupervised one. So this means that we have to integrate the supervised and unsupervised. So some of them use the data set, some other does not actually require the data set for the tree. Does this answer the question?
I'm still not getting it because my understanding is that you have different vendors like Ericsson, Nokia, just to name a few. But my understanding is you don't select them all, or how does it work? Or do you mean that you select one radio network on one day and another radio network on another day, and these radio networks have to be there already? Is that the case?
Yes. So here, once the service provider, like let's say Orange or Vodafone, once they agree to participate in this open 5G architecture, so they announce the resources that they are going to participate with. And these resources will be actually stored in this repository, okay? And then the system actually will choose the best service provider. Yeah. So this answers your question. Yeah. Yeah, sorry, there is like 3 or 4 presentations that I have already cut for the sake of the time. But yes, this is part of the system actually. So this is the service provisioning model, which is used to select the best service provider that can integrate or that can work with the model. And this service provider actually, this is why we use the zero trust actually. So the zero trust is used in this service provision as part of this component. So in order to choose the best service provider, you need to choose the one which provides the best performance, cost metric, and security trust. And security trust is evaluated using the models that I have just introduced today. So this is just one of the parameters here. And once you have these 3 parameters, then you can choose the best service providers that can provide this service. So this can be like Amazon for cloud. This can be Nokia or not Nokia, actually Orange or Vodafone for the radio access network resources. So it is based on these 3 parameters. So it's like a multi-criteria decision-making approach, which can help you to select the best service provider based on these key performance indicators of each of these vendors. Yeah.
Thank you. Anybody? Yeah.
So thank you for the presentation. It was very great. So as I understood, one of the ideas is to have like this generalized 5G framework where any customer can connect to any mast basically. But what is the incentive, for example, Verizon to provide access to other like telecom customers?
Yeah, it's an excellent question. Thank you. Well, so the idea here is that for the open 5G architecture is that you want to make the best use of the vendor resources, right? So sometimes Verizon, they have some access points that are not used in some rural area, right? But this can be used by AT&T company, right? Because they are paid for this, right? So once they are using their access points, and they have just their antenna, but they don't have access points. So they can use the access points of Orange, and they can integrate it with the antenna of Verizon. And they will actually pay for Orange for using their access points. So it is like an economical model. for the vendors or commercial vendors to work together and to provide this service. Does this answer your question? Yeah, thank you.
There is possible, yes, coming.
Yes, so this slide about collaboration, it was interesting that you presented this call for Norfolk.
Yeah, let me. Yeah.
So can you tell us very briefly about the context of such calls that are shared between NSF and the European countries? And have you had some of these collaborations before? And how do you think about the context of this collaboration, knowing the NAIC activities that you have seen?
Well, so actually, when I looked at these topics, some of them actually include like some systems related to the sensitive data and security, like risk assessment and security. Some others are related to the service federation, and these are components of the current NIC project, right? And with the facilities that we have there, so we can actually allow like remote access to all this infrastructure for the team. And we already have actually some international collaboration with South Korea, as an example, with Qatar, with Pisa University in Italy, and with Lyon University. So we have this kind of international collaboration based on the resources that we have and the data sets that we also have there, and we open such kind of collaboration. And I see that this is really a great opportunity actually to work together and to use this real-time implementations that we currently have and to integrate this work to the systems that you have already developed. I have seen a great work actually that you guys have already introduced. So I think by integrating these models together, we will end with a practical work. Because in our labs, actually, most of our work are based on military-based application. And for military, they take care of the prototypes, data sets, test beds. They don't care about publication or theoretical work. So all our deliverables, our outcomes are prototypes and software. This is why we work with Ericsson, we work with Metri, so that once we develop this prototype, we share these prototypes with them. And then they extend it. So they extend it, and then they improve it. And I see that like the current work can be actually adjusted to a certain domain. This can be like the 5G or the drone, or because these are among the future domains that people are interested in. Right? Does this answer the question? Okay.
Any more questions, comments? Nice. With this, we are thanking very much about Dr. Hisham Kholidy, and then we are going to lunch. But now give a big applause.